So it's great to be here at PyData. I wish Wes could be here. He's always great to interact with. Like I said, I'm going to be talking about Project Jupyter, and in particular the notebook, and a bit about myself here. So first of all, I'm going to be giving the entire talk using the Jupyter notebook, just to see sort of where we're at with everyone in the room. How many people here have used the Jupyter notebook before? Okay, fantastic. So because of that, I won't spend quite as much time as I normally would giving an introduction, and I'll try to talk about some of the more interesting and advanced part of the project. But I also think it's useful to give a little bit of background about how the Jupyter notebook came to be. So you can see here my quote day job is as a physics and data science professor at Cal Poly. Cal Poly is a California state school on the central coast of California, where it is most certainly not raining today and hasn't probably for 2 years. I was trained as a physicist at the University of Colorado, computational and theoretical atomic physics. And at least in my own journey, how I got involved in open source was I found that the places where I was struggling most in my physics research was not the physics, but was really the computational tools that I was using, and in particular using and starting to use with students. And that was a very painful thing, and that got me to start to think about building tools. I will talk in a few minutes about why Jupyter and IPython. Where are there two things? Why do we talk more about Jupyter now than we talk about IPython? And here's a short sort of outline. And the thing I want to start with is the idea of a computational narrative. And this really underpins and is a foundation for a lot of the way that we think about interactive computing. I apologize, the visibility of the screen is not fantastic. Let's see. I know that's better, but it also gets worse because so little can be seen on the screen. How bad is this in back? It's bad. So I will say, there's a lot of chairs up closer. Could you please move closer? If I do this, well, we'll see. A lot of it starts to look horrible when there's more content on the page. But we'll do this for a little while. I can also do some of this to get a little more space on the screen. So computational narratives. The first observation is that computers are good at consuming, producing, and processing data. This is really what we as humans build computers for. Humans, on the other hand, are good at consuming, producing, and processing narratives or stories. And if you doubt this, just look at the excitement about Star Wars that's coming out, right? A lot of us grew up seeing the Star Wars movies, and they're really compelling for many people. And there's a lot of excitement around stories. You can also see the remnant of the fact that a significant fraction of the entire internet is occupied in serving stories in the form of Netflix. People are compelled by stories. And because of this, for data to be useful to us as humans, we need tools for telling stories that involve code and data. And some of you in the room may have seen this example before that sort of illustrates this idea, the distinction between code and data and the embedding of that into a story. So you've probably seen a lot of this stuff already. I'm going to load up matplotlib. I'm actually not going to use that. Read in a data frame. You can look at the data frame. You can see there's some data here about city, police force size, and then some percentages that are broken down by race. And we've got 76 records. We can do some summary statistics, some transformations. Here's a reduced data set, and then use Seaborn to make a plot. And at this point, I think it's fairly safe to say that none of you would be willing to risk your life based on the data that you've seen, even though there's a nice, pretty plot. And yet the narrative around this data is one in which many people were willing to risk their lives. And the underlying story here comes from Ferguson, Missouri, from the end of last year. This is a data set that was written about in 538 entitled "Most Police Don't Live in the Cities They Serve." And just to read a quote from the article, in Ferguson, Missouri, where protests continue following the shooting of a teenager by a police officer this month, more than 2/3 of the civilian population is black. Only 11% of the police force is. The racial disparity is troubling enough on its own, but it's also suggestive of another type of misrepresentation. Given Ferguson's racial gap, it's likely that many of its police officers live outside the city limits. And so back to the box plot up here, what I'm showing you is a percentage of police officers that live in the cities they serve. I think that's right. Let's see. Non-white officers are more likely to live in the cities they serve. White officers tend to live elsewhere. And obviously, there's many different ways that you could approach the events in Ferguson, Missouri from a data perspective. This is just one of them. But again, the point that I want to make is that without the story, without the narrative, the data really doesn't mean too much to us. We're not really willing to make decisions based on that or have it affect our lives in a meaningful way. And so this idea of a computational narrative is really foundational when we think about interactive computing. And to put it bluntly, if all you have is code and data and there's no narrative, it just doesn't mean much. No one is going to be able to do much with that from a practical perspective. So, So IPython and Jupyter, our main goals are centered around interactive computing. First of all, we, since the beginning, have offered an environment for doing computations that are interactive, that involve some sort of human steering of the computation in the middle while the computation is live. And then this idea of a computational narrative around that interactive computation. IPython was started in 2001 by Fernando Perez. Fernando and I were classmates in graduate school at the University of Colorado. Between 2001 and 2004, Fernando and I had conversations where he was really excited about this new Python thing and thought it was going to really change how everyone did computing. And I think it's interesting from a historical perspective that even all the way back then in 2001, the excitement that Fernando had about Python was completely present. It was fully realized. It's not, at the time, I had no sense that this was a really risky, crazy thing. It was like, no, of course, it has to be Python. It's amazing. It's fantastic. At the time, he and I were doing a lot of our PhD work using C++, Mathematica, Perl, other tools like that. And he started IPython because of his pain, trying to get work done. I joined IPython and started to work with Fernando in 2004. And between 2004 and 2011, we continued to do a lot of work on the traditional terminal-based IPython. And in fact, we made multiple attempts during those years to build an interactive web-based notebook. And all those attempts got thrown away. So maybe from your perspective, the notebook sort of spontaneously came into existence in 2011. It was a very slow, painful process for us to understand the abstractions. How do you build something like this? And also, a lot of the tools around web technologies were extremely primitive at the time. And a lot of the things that we do just weren't possible at the time. We probably could have done it, but it would have been really, really painful and honestly beyond our capabilities at the time. So the notebook came out in 2011. Shortly thereafter, we started to really understand that the architecture behind the notebook, and that's really two things. One is the document format itself. So when you look at the file system where you're running the Jupyter or IPython notebook, what you see is a bunch of files with a .ipynb extension. The notebook files are JSON data that store both the code for computation, the narrative text around the code, and then all results related to that code, including visualizations. And so that's one piece of the architecture. Another piece is the network protocol that we use for the web browser to communicate with the back-end process, which we call the kernel, that runs code in a particular language. And the realization was, for the most part, those two abstractions were completely independent of Python. We had a few small places where we were sort of had Pythonisms present. Over the subsequent years, we removed all of those and built an architecture that is really meant to be language independent. And so, for example, so if I go to tempNB, I thought, yeah, sorry, I probably don't have a network connection. No, okay. It could be fun firewall things. Let's see, temp B. Okay, sorry. I will refrain from saying anything at this point about people breaking the internet. If you were to go to tempNB, you can see that there's a drop-down menu where you can select between a number of different languages, ranging from Python 2, Python 3, Julia, R, Scala, and Spark. Back here, the representation that is right here. I only have the Bash, Python 3, and R kernels installed. So as we built out the language independent aspects of the project, it really became problematic trying to explain to people that they should run their Julia code in an environment called IPython, or that they should run their R code in an environment called IPython. So last summer, we started a new project. It's really the same group of people that have been building IPython all along that we're calling Jupyter. And Jupyter is the new home for all of the language independent pieces of this architecture. You may be wondering, well, what about IPython? Has it gone away? No, IPython continues to exist. It is the Python specific parts of the architecture. So if we go here and go over to this page, this is a list of the current kernels that we know of that have been written for Jupyter. And what you see here, iJulia is the kernel for Jupyter that runs code in Julia. iHaskell for Haskell, iF# for F#, iRuby, and so on. So at this point, IPython is one among many peers as a kernel that can run code in a particular language on the Jupyter architecture. I think that's all I want to cover in that notebook. I'm actually, for now, going to skip my standard notebook tour. It sounds like most of the audience uses the notebook and would probably fall asleep if I cover that content. I do want to mention briefly this Bash notebook. Bash is one of the kernels that exists for Jupyter, and I think for me this emphasizes the narrative aspect of this. Now you might say, well, why do I need a Bash kernel when I can go over here and just say new terminal, and I can run arbitrary code here in Bash, I can start up VI, do anything I want right from the web browser. Why do I need a notebook? And it really gets back to this idea of a narrative and being able to construct a narrative that has the code that's reproducible. There are a lot of existing command line tools that different groups use that their workflow is basically a bunch of Bash commands linked together. With the notebook, you can combine those Bash commands into a narrative that's reproducible. And so, I mean, this is not a particularly interesting narrative. It's just showing you that here the Bash kernel works as the other kernels. So for example, you can define a variable in Bash, and in the next cell, access that variable. The kernel is stateful, just like the other kernels. Tab completion works. So we can say, right? I can tab complete and say, maybe I want to easy install something. You can even define Bash functions. Here's a display function that taps into the display architecture of the notebook. And when I cat an image and pipe it to that function, I see the image here in the notebook. In case you haven't seen it, the notebook generalizes the idea of output beyond just textual output to include other MIME types. So image MIME types, SVG, HTML, JavaScript, even LaTeX.
Can you show that function just one more time?
Yes. Yeah. So the function is a little bit of magic, but basically what this does is the bash kernel watches the file system for files that are put in a particular place, and when they are, it grabs the data and sends it back to the notebook using our display message protocols. Most of the other kernels handle display in a slightly more sophisticated way. The bash kernel is somewhat simplistic, but it's also really nice because you end up being able to do things like this that, from a conceptual perspective, make a lot of sense. The notebook ecosystem. So around the notebook, there are a lot of other tools. I'm mostly here going to talk about tools that we ourselves as a project build and maintain. The first is NBConvert. NBConvert is a command line tool for converting notebook files to different static formats. This includes static HTML, Markdown, restructured text, LaTeX and PDF, and then Reveal.js slideshows. Next is NBViewer. NBViewer is basically NBConvert as a website. So let's see if I have enough. Yay, I have enough internet. So this is the NBViewer website, and you can paste the URL or the GitHub information for any notebook that's public, and we will render that as static HTML. And so here's just an example. This is a notebook that looks at the XKCD style plotting in Matplotlib. And the important thing here is that the code, it still looks like a notebook visually, but the code is not, can't be edited, and it also cannot be run in this context. And initially, Matthias, one of our core devs, developed NBViewer over a weekend, and we said, well, let's try putting it up. And it's turned out to be extremely popular as a way of sharing technical content. If you think about it, a few years ago, if you had a document that had code and data and mathematical equations, and you wanted to share it with people and tweet about it, where would you post that? I mean, you could try to post this on a blog, which was difficult. And part of what we're also finding is that the other venue people would post these things were like formal academic publications. The difficulty with that is that the time scales for it are really long. By the time it actually gets published, you're probably long working on something else. And also the accessibility question. Many, if not most, academic journals are not freely available to the public. You have to be at a relatively wealthy US university that has subscription to those journals. Otherwise, people can't look at it. And so NBViewer has been very useful for sharing notebook-based content. As I mentioned in my talk yesterday, as of spring of this year, GitHub also renders notebooks in place on GitHub. The big difference between the notebook rendering on GitHub versus NBViewer, and actually let me go back to NBViewer, show you an example here. So this is a notebook that has bokeh visualizations, and we can just pick linked brushing. So notice it says bokeh.js successfully loaded, and then when I go down here, I have live interactive plotting on NBViewer. And as I mentioned, the notebook documents contain all of the output in all the different formats. And this is how a library like Bokeh works. It embeds JavaScript and HTML in the output area. And when that notebook gets moved around, that runs and you can see the visualization. The problem with that from a security perspective is that I could write a notebook that contained arbitrary JavaScript, and you are then going to open that on a computer that likely has something valuable. For example, like all of your files. You can imagine the difficulty if GitHub allowed arbitrary JavaScript from notebooks to run on GitHub. For example, someone could write a notebook that simply deletes all of your GitHub repositories. That would be a very unpopular feature. And so GitHub cleans most of the HTML and all of the JavaScript when the notebooks are rendered on their platform. It's really unfortunate, but I don't see that changing anytime soon. I think it's a very good reason. On NB Viewer, we have no authentication contexts whatsoever, and so it's a fairly safe platform for us to allow arbitrary JavaScript. So that's an important difference. All right. This is really an advertisement for a talk by Jeremy Freeman. Jeremy, are you here in the room? All right, he's probably getting ready for his talk. A project called Binder. And I'm not going to spend a lot of time because you should just go to his talk here at PyData and hear about it. So we have the ability to share notebooks on GitHub, render them on GitHub or NB Viewer. But what you would really like is for users on the internet to be able to actually play with your code. And that's exactly what Binder offers. With Binder, you basically get a little badge on your GitHub repository, and then anyone in the world can run that code. So go to Jeremy Freeman's talk. I don't know exactly when it is. I think it is this afternoon, but you can look at that up. TempNB is another, it's a website that's broken here at Bank of America. It is another website that you can visit to get a sort of a transient notebook server in a Docker container. We find that TempNB is really nice for quick demos. So you're someplace, you don't have your laptop, and someone says, well, what about that differential equation or that function, or can we plot this? And you say, I have TempNB, tempnb.org. You've got notebooks in Python 2, Python 3, R, Julia, and I think Scala and Spark as well. It's all right there. Now, TempNB is not designed for persistent work. The notebook, after you leave your TempNB Docker container, a short while later, we blast it away, and all of the work you've done is going to vanish. So don't use it for important work. You will be disappointed. Jupyter Hub, on the other hand, is a multi-user server that's designed to run in a persistent manner for organizations. So for example, at Cal Poly, where I teach, our college has a Jupyter Hub deployment that everyone in the college, all students, all faculty can use, that's connected on the back end to our cluster, integrated with our Active Directory authentication. Here's just a screenshot of a demo Jupyter Hub instance that we have. There's two aspects of Jupyter Hub that are pluggable. The first is the authentication. By default, it uses PAN-based authentication on Unix systems, but we also have support for OAuth, in particular Google and GitHub OAuth. And so this particular server is using GitHub OAuth, and I can simply add a new account by asking for someone's username on GitHub. Very nice. And I want to emphasize that all the work you do on a Jupyter Hub instance is persistent. So your notebooks will be there 2 weeks when you come back. So I think one of the most fun aspects of working on this project is seeing what different people are doing with the notebook. And so I want to spend some time just walking you through some really interesting applications of it. First, in the area of publishing. Matthew Russell has written a very nice O'Reilly book called Mining the Social Web that includes Jupyter notebooks for all of the examples. Another great example is of a more traditional academic book is this book, Python for Signal Processing by Jose and Pinko. It's a Springer title, and it's an actual sort of traditional hardback academic book. And he wrote the book originally as a series of blog posts that were IPython notebooks, and then took those notebooks to Springer and began to work with them on the book. For technical blogging, I think one of the best examples of this is the Pythonic Perambulations by Jake Vanderplas at the University of Washington. If you have not read his blog, I highly encourage it. He is an excellent author at really, in our words, building computational narratives, right? Building a story around code and data. And so when Jake publishes a blog post like this, you can see there's equations here, there's code, there's visualizations. All of this started out as an IPython notebook, which Jake then uses NB-convert to convert it to static HTML. And I think the blog engine he uses is Pelican that has integration with this as well. Jake has also written some more formal works. He wrote this blog post for Scientific American on 4-dimensional distributions of asteroids. And again, it started out as a notebook. Another really exciting thing is what O'Reilly Media is doing. They're embracing the notebook at a fairly deep level. The first is that they have this new learning site. And here's an example. Actually, this is another example from Jake Vanderplas, Introduction to SVMs. And let's actually see beta. Yes, so here I can show you the live website. So here's some content on the O'Reilly website. And the code has a little run button here. And the second I hit run, it fires up a notebook server behind the scenes. Now, it doesn't use the actual notebook user interface. It only uses the kernels. And it actually is running on top of tempNB. And all of the code is live code. I can go in and change it, modify it. And it's an example where someone is taking the fundamental building blocks required for interactive computing. Namely, you need a process that runs code, and you need the ability to communicate with that process through some means. But deploying it in a context where there's no notebook present, right? And along with this actual website, O'Reilly has this open source project called Thebe, and the GitHub link is here. That is basically the JavaScript required to put those code cells onto any web page that you want. So that's another example of that. Here is an example from academic publications. I should mention the notebook gallery is on our wiki page in the IPython repo, and we have a very, very long list of just interesting notebooks that we think are notable. And there is a section on actual peer-reviewed research. This is one example. So this is a paper written in Nature Genetics. Here's a screenshot of the actual Nature website. And then associated with that is a GitHub repository. That's odd. Sorry, I think I will have to figure out what's going on with that link. But they have a GitHub repository that has all of their analyses for the paper as Jupyter notebooks. And I think let's actually, let me see. Part of what I think is really interesting about this case is the amount of material that they have provided here. And I think one part about reproducibility in data science and scientific computing, whether it's in an academic setting or not, is that typically the thing that shows up at the end of the day as an article, a blog post, is just the tip of the iceberg. The actual analysis that went into it is massive. And so, I mean, there's probably, 20 different notebooks here. And let's just pick one of those 20 notebooks and look at it. So again, look at the length of the scroll bar on the right. It's incredible. Now, when I first saw this, I think part of my response was, wow, that's a little bit like overkill maybe. But when you think about it, how much worse is it that someone would publish an article requiring this much analysis and leave that analysis out? There's no way anyone would ever be able to reproduce that work. And I think this is a really important point to remember about reproducibility. Here's another short example. Actually, I'm going to skip that one. Want to jump ahead. So here's some examples of the notebook being used in journalism. And the first is from Jeremy Singer-Vine and John Templon at BuzzFeed News. I know you pretty much probably don't associate BuzzFeed with serious data-driven journalism, but Jeremy and John Templon and some other people there in their group are doing absolutely fantastic work. And in our minds, really setting a gold standard for what it means to do reproducible data science. So here is their GitHub organization. They have a repo entitled Everything that is an index. Every article they write that's backed by data is given its own GitHub repository. And that GitHub repository contains both the data for the article and the code and analysis as Jupyter notebooks. Right, and so here's one example. Here's the article. Immigration authorities are far more likely to jail you if you're Mexican. Sort of has a traditional like BuzzFeed twist on the title of the article, but a rather serious issue. And here's a screenshot of the GitHub repository with the analysis behind that. And again, part of what's so notable about this is that they have committed to do this for all of their data-driven articles. They're not sort of after the fact making sort of decisions about, well, should we open this one up or not? They've just said, we're doing this for everything. The LA Times has recently gotten into this game as well. This is a fairly recent article about the LAPD misreporting how serious crimes are to try to make it appear that crime is going down under their watch, when actually that was not the case. And the analysis was quite significant, and again, they posted their data and the analysis on GitHub. The last thing I want to talk about is the usage of the Jupyter Notebook in commercial products. And this is one point that I think is quite important. Jupyter and IPython are completely open source projects. We're licensed under the 3-clause BSD license. And it's not just about our using of an open source license. It's also the fact that all the development on our project is done out in the open. That's not to say we don't occasionally have private conversations, but we try very hard after we have private conversations to post a summary to GitHub or to our mailing list. It's turned out to be quite challenging to engage with large companies, and in particular, how to find a level playing field where all of these different companies, many of whom compete directly against each other, can come together and work on the project. And we're really pleased with how this is going, but we will be the first ones to acknowledge that this is really a growing period for us and these companies figuring out how do we do this together. One of the early examples of the notebook being used in a commercial product is the Quantopian research platform. Quantopian is a Boston-based algorithmic trading platform. I think some of the Quantopian people are here at PyData. They're doing absolutely fantastic work, and their entire research platform is based on the Jupyter Notebook. This summer, Microsoft released two products that have the Jupyter Notebook as the user interface. One is Azure ML, which is their machine learning platform on their cloud platform, Azure. And the other is HD Insight. HD Insight provides Spark clusters as a service. And the user interface for that is, again, the Jupyter Notebook. Dataiku offers a product called the Data Science Studio. This is an on-premise data science environment. And again, the user interface for this is, again, the Jupyter Notebook. DataRobot is building a machine learning platform that helps you sift through different classifiers and find one that works well for your data. And one of the interfaces that they offer is the Jupyter Notebook. A fairly recent addition to this space is the Google Cloud Data Lab. This is there's a couple different efforts at Google involving the Jupyter Notebook. This is one particular one. And basically, you can see here, import gcp.bigquery as bcube. So the idea is that they want an interactive platform for you to use their different cloud-based services and are offering the notebook in that. White Hat Rodeo is another interesting take on this. This is a completely separate user interface than the Jupyter Notebook web application, but underneath that still reuses all of the architecture. So they're still using Jupyter kernels and the network protocols and some aspects of the server as well. We're really excited to see where sort of the intersection of open source tools and the application of those in commercial products. And I think with that, I will wrap up. And I think we maybe have time for a few questions. All right, fire away. Or not.
Already in your recent, thank you. I read in your recent grant proposal the intent to make notebooks more like regular software when it comes to modularization, testing, collaboration, versioning. Can you talk about that a little bit, maybe?
Yeah. There's much more than I can talk about quickly. If you go to the blog.jupyter.org, new funding for Jupyter, there's a blog post that talks a lot more about this. We are currently in the process of breaking our monolithic JavaScript front-end code base into a lot of loosely coupled NPM packages, and then reassembling those in a way that really emphasizes extensibility. And so we're going to have, basically, if you have an NPM package, we will make it very easy for you to get that into our user interface and integrate with all of our APIs.
So the Bash kernel looks really cool. I hadn't known about that. That might be a big blessing for sysadmins.
Yeah.
But is there an EXO and SH kernel yet?
A what kernel?
EXO and SH, you know, the kernel that has...
Oh, yes, that Anthony Skopats has.
Yeah, exactly.
I don't know.
I'm looking at having to integrate a new IDE into an existing monolithic program. Would I be better off waiting until you finish the refactoring, or should I start now?
Yes, yes. No, the refactoring is happening very quickly, and within a few months, you can start to build on this stuff.
I have a feature request.
Yes.
So whenever you open the notebook, you hit the menu bar and you hit the other bar. Can we have a global checkbox that does it on all notebooks?
Always?
No, I want to check. I know I can edit the CSS files and the JavaScript files to inject, hide them.
To make it easier to
make that easier to turn back on and off, because, I mean...
Yeah. Thank you. Good idea.
What did you consider best practice for using IPython notebooks with Conda environments? It's... because I know you can, with each environment, it can include IPython notebooks, but it gets pretty hard to keep track unless you organize everything in different directories about which environment you're using.
Yeah, so the way that I think a lot of us are starting to do that is to basically just install kernels to the different environments and then launch the notebook server once and then be able to pick in your list of kernels from the different environments.
The environments auto-register?
So I would have to look it up. There's a few people that have started to write tools to do that type of thing.
Studio people did something very similar.
Yeah, so that we can talk afterwards, or I can, yeah, it does exist.
Okay,
We should stop.
thanks.
Thank you.